Hello, Mr. Burke.
Hello, Mr. Mazzolini.
Well, in chemistry, we've been doing stoichiometry problems,
We have,
and they've been doing a pretty good job of it.
for the most part.
Yeah, for the most part. And the problems we've been doing sort of look like this reaction that we have in front of us, except usually they just give us the amount for one of the reactants.
Exactly.
One or the other. And the other one, like in this one, is a combustion problem, right? You have sucrose, and it's burning, and it's producing CO2 and H2O. And it's usually a problem like, well, you have this 10 grams of sucrose, and it's burning in air.
Right.
And that means you have plenty of oxygen. Now, this is different. You only have 10 grams of oxygen. And we're trying to find water. So how do we go about this particular problem?
Well, we have to figure out which one of the two reactants is going to get used up first.
Okay. How do we go about that? I mean,
Same way as we've done all the other stoichiometric problems. Convert grams to moles, moles to grams, and then do a comparison between the two reactants and see which one makes less water.
okay, so we're after which one of these two reactants actually produces the less amount.
Exactly.
And that one will be the one we run out of first?
Exactly.
Okay. So that's what we're going to do.
Okay.
So we're going to start off with 10 grams sucrose, which I'm going to abbreviate SU.
Okay.
And I'm going to put 1 mole up top because that's what we want to get to.
Right.
I'm going to put the molar mass on the bottom. So what is that?
Molar mass of sucrose is 342.2948 grams.
Good. Now I'm going to go ahead and cross out on the way
Okay.
so I know what units we're in. We're moles of sucrose right now. So now at this point we have to use that mole conversion. And that's why we have this nice balanced equation here. So according to this equation, we have 1 mole of sucrose to every 11 moles of water.
Yep.
It's a lot of water.
It is.
So moles of sucrose cancel out, and your moles of water. And then the last step is just getting back, as you said, back to grams.
Right.
So 1 mole of water is
18.0152 grams of water.
Oops, I'll put the O down there. So moles of water cancel out as well. So we're left with grams of water, and that's really what we want to get to anyway.
Yep.
And what's our answer for that one?
5.79 grams of water.
5.79 grams. So, but we can't stop there, right?
No, that only tells us half the story.
Right. If we were just using sucrose and we had plenty of oxygen, then that would be our answer, right?
That would be our answer,
Okay,
right.
but that's not the case here. We have this other reactant. In fact, it is oxygen. And we're going to do the same thing to oxygen. We're going to change it to moles.
Right.
And we're just going to put 32 grams down below. Grams of oxygen would cancel out at that point. And then we have a mole ratio again.
Right.
Now this mole ratio says 12 moles
Right.
of oxygen for every 11 moles of water. It's a lot of oxygen you have to use to burn sucrose.
Yep.
So the same thing happens in our body, I suppose. That's why we need to keep on breathing. So we have 1 mole of H2O down below and
18.0152.
0.0152 grams up top of H2O. And it's the same one at the top. It looks like we can use a lot of information as we go.
Yeah, don't have to reinvent the wheel.
That's right. So those cancel out. And we are in grams
Of water.
Not really.
What happened?
You know, I don't really know. I don't.
Yeah. Pipe break.
Sorry for the glitch there. But what's our answer to this one?
5.17 grams of water.
5 point. Oops. My stylus is having issues. 5.7.
Oh, no, 1.7.
5.17 grams.
Right.
Okay. Well, clearly there's a difference there. We have less water being produced by the 10 grams of oxygen than we do by the sucrose. So what does that mean about our limiting reactant? Which one is it?
Oxygen is the limiting reactant
So oxygen's a limiting reactant.
because it gets used up first.
Exactly. So we'll call that's the limiting reactant. Now, what's the importance of that limiting reactant to the rest of this problem?
Well, it tells us how much product we're going to have, and it also helps us to establish what excess or how much excess we have of the other reactant.
Exactly. Good. So we can say if the question was how many grams of water would we produce from this reaction,
Right.
the answer would be this 5.7, right?
5.17, right.
5.17. So not only did we find the limiting reactant, we also found the answer to that one question.
Exactly.
Good. Well, that looks like a wrap. We'll do another one to show some more of this reaction later on.
Like how much sugar we've got left over.
Exactly.
Sounds good.
Thank you, Ms. Burke.
Thank you, sir.